Okay, let's start with Ohm's law. So any material, it contains property to oppose the flow of electrons are called as energy. It is depends upon the material. So that is called resistance. So materials எல்லாமே having the property to oppose the flow of electrons. So அந்த property என்ன சொல்றோம் அப்படின்னா that is called resistance அப்படின்னு சொல்றோம். So definition for resistance அப்படின்னா it resists to flow of electrons, that is called resistance. So resistance is the what is resist the flow of electrons, resists the flow of electrons or flow of charge, flow of flow of charge. So this resistance property is very depends upon the material and also it is depends upon the length and cross section area of the conductor. Resistance property or this resistance is denoted by R, that is depends upon rho L by A, rho L by A. Okay, it means that the rho is the resistivity of the material. Rho you can call it as resistivity of the material in ohm meter. The unit of resistivity is ohm meter. And length of the L denotes the length of the material in meter, and the next one is area of the cross section, area of the cross section in meter square, so take it in the mark, take it as a conductor. So in the conductor இதோட resistivity எதை டிபெண்ட் பண்ணி இருக்கும் அப்படின்னா this the length of the conductor and cross section area. Cross section area ங்கிறது how thickness this conductor, that is called cross section area. So here this is the conductor, this is the cross section area, this is the cross section area, this is called cross section area, and this is the length of the length of the conductor, this is the cross section area. Rho அப்படிங்கிறது it depends upon the material தன்மை, that is copper, aluminum, that is all that is all having low resistivity. So low resistivity அப்படின்னா it allows more electrons to flow, அதான் வந்து low resistivity. High resistivity material அப்படிங்கிறது it will not allow the electrons to flow, that is electrons are charged, both are same, right? So this is about resistance. So low resistance materials எடுத்துட்டீங்கன்னா rho resistive material. So rho denotes the resistivity. Rho denotes the resistivity. So low resistance materials, in low resistance materials allow more number of electrons. Example for low resistive material are copper and aluminum. Copper and aluminum are the one of the example, one or two of the examples of a low resistive material. And high resistive material, that is high resistive material, that is called paper and mica are the high resistive material. Paper and mica, these two are high resistive material, right? So these are about resistance. What is resistance? So also the resistance, one more thing, the resistance R is mainly depends upon the temperature. Also depends or depends on, or is depends on temperature. Why the R is depends upon temperature? If the temperature is increased, அப்படின்னா, the length and cross section area of the conductor more. The length and cross section area of the conductor will be vary if the temperature is changed. So resistance is depends upon the mainly temperature. So this is about resistance. So resistance na enna அப்படிங்கறதோட definition. The resistance is the property of any kind of material, right? Next, this resistance property, நம்ம resistance அப்படிங்கறது we are using conductor. நம்ம resistance அப்படிங்க in a circuit we are using conductor, அதான் வந்து resistance அப்படின்னு சொல்றோம். So modeling of this resistance property and we are including in the சர்க்யூட்டில் இன்க்ளூட் பண்ணணும். ஸோ அப்போ இந்த ரெசிஸ்டன்ஸ் ப்ராப்பர்ட்டியை மாடல் பண்ணணும். ஸோ மாடல் மீன்ஸ் யூ ஹேவ் டு இன்க்ளூட் இன் தி சர்க்யூட். ஸோ அப்போ வி ஆர் டெவலப்பிங் ஒன் ரெசிஸ்டன்ஸ். இந்த ப்ராப்பர்ட்டியை கண்டெயின் பண்ணியிருக்கக்கூடிய ஒரு மாடல் பண்ணுறோம், தட் இஸ் கால் ஒரு எலமெண்ட் பண்ணுறோம், தட் இஸ் கால் ரெசிஸ்டன்ஸ் அப்படின்னு சொல்கிறோம். அந்த எலமெண்ட்டுக்கு பேர் என்ன? ரெசிஸ்டர். ஸோ நெக்ஸ்ட் ஒன் இஸ் ரெசிஸ்டர். SISTOR, resistor. It is denoted by R. Resistor is denoted by the symbol R. The unit is ohm. Unit is ohms. Unit is ohm. The symbol of a resistor is this is point terminal A, terminal B, and plus minus. Across we have VAB voltage and current is in I. This is the symbol of resistor. So two positive and negative terminal, across these two terminal the voltage is VAB and current entering always in the positive terminal of the resistor, right? So this is the resistance. We are modeling the resistor for the having the characteristics of resistance property. Okay. Next, one physics scientist, that is George Seaman Ohm. George Seaman Ohm is a scientist. So இவர் என்ன பண்றாரு அப்படின்னா, he wants to know the relationship between current and voltage in a resistance. He wants to know the relationship between current and voltage in the resistor. So ஒரு experiment conduct பண்றார், ஒரு law develop பண்றார், that law is called Ohms. So he wants to analyze the current flowing through the resistor or between and with respect to voltage across the resistor. So that is called Ohm's law. That is called Ohm's law. So because of his remembrance of George Seaman Ohm, the unit of resistance is Ohm. Unit of resistance is Ohm and denoted by capital letter R. So what Ohms give the definition, that the current flowing through the resistance is directly proportional to the voltage across the two, that is potential difference across the two terminal of the conductor. Being defined. What is the definition? The Ohms given is the current flowing through the resistor or addition conductor is directly proportional to the potential difference across the two ends of the conductor. That is the definition given by the Ohms at constant temperature. It is a very important term, at constant temperature, because of the temperature is changing the property of resistance. So temperature changes the property of the resistance. So he defines that the voltage across the two terminal of the conductor is directly proportional to the current flowing through the conductor at constant temperature. Okay. So definition: current entering to the conductor is directly proportional to the potential difference potential difference across two ends of the conductor. One more thing, constant constant temperature. At constant temperature is a very important step. So current entering to the conductor is directly proportional to the potential difference across the two ends of the conductor at constant temperature. Right? Next, the property of the resistor. So resistor is an nothing. So resistor, change that. So resistor is a passive device. Resistor is a passive device or passive. So resistor is a passive element. Resistor is a passive element. It will not generate any current. It will not amplify the power, or it will not do anything. So resistor is a passive element. Also, it is a linear element. It is a linear. So this we need to. So resistor is a device. Resistor is a device. It is a passive element, and also it is a linear element. Passive element and linear element. This is the about resistor. Now next we are going to discuss about conductance and conductivity. So this is the resistance. And so we are introducing one proportionality constant, that is 1 by R into I. One second please. So I is directly proportional to V. I is directly proportional to V. So we are here we are introducing one proportionality constant, that is 1 equal to 1 by R into V. That is 1 by R, that is resistivity of the material. So you can rewrite I equal to V by R. I equal to V by R, also V equal to I R, V equal to I R, and also R equal to V by I. This is the equations derived by the Siemens ohm. So I directly proportional to V. So we are introducing proportionality constant 1 by R, that is proportionality constant 1 by R, that is proportionality constant. We are introducing proportionality constant V by R. So V equal to IR, R equal to V I. It's about, this is all about resistance. And we have this, how the resistance have a resistance and resistive property. The same way they have a conductivity and conductance. So conductivity is equal to Siemens per meter, that is equal to Siemens per meter. Next, conductivity is, that is 1 by R, that is the unit of conductor is mho, mho. The reciprocal of conductor, the symbol of resistor, that is ohm, is this is here. The symbol of this here. So symbol of resistance, that is ohm, the symbol of resistance is ohm. This is conductance and conductivity. Next, what is the value of resistance at short circuit and open circuit? We are going to discuss now. Circuit. This voltage is current. So at short circuit condition, what is the value of voltage? So at short circuit condition, voltage equal to 0. So current will be the maximum, right? So at short circuit condition, we have only voltage, only we have a current. Sorry. So short circuit condition, we have only current. So V equal to 0, I equal to R equal to V by I. So R equal to V by I. So putting 0 divided by I, R equal to 0 ohm. R equal to 0 ohm. At short circuit condition, the resistance is 0. What will be the resistance at open circuit? R at open circuit, or at open circuit, this current and voltage. So at open circuit, we have only voltage. The current will be the 0. So so V equal to V, then I equal to 0. So resistor equal to V divided by 0. So 0 divided by, so 0 divided by anything, that is equal to infinite ohm. That is equal to infinite. So at open circuit the resistance is infinite, and short circuit the resistance is 0 ohm, right? So next we are going to temperature coefficient of the resistor. What is the temperature coefficient? So resistance is a positive temperature coefficient. Temperature coefficient, that is discussed regarding, that is temperature temperature coefficient. So the material we are taking as a conductor. Conductor, it is a temperature. Sorry, this first one is resistivity, and another one is the temperature. In a conductor, if the resistor, sorry, first, sorry, in a temperature coefficient conductor, we are taking first one is temperature, another one is resistance. In a conductor, the temperature increases, the resistivity will also increase. So the conductor is a positive temperature coefficient. So resistance is a positive temperature coefficient, and we have an insulator. Next material is, we have insulator, and another one is semiconductor. Semiconductor. So insulator and semiconductor, if the temperature increases, the resistivity will be decreased. So that is, temperature increase, resistivity will decrease. That is negative temperature coefficient. This is the, that's why in a Ohms defined that the Ohms law only applicable at constant temperature. Applicable only in constant temperature. If the temperature varies, the property of resistance will be changed. So resistor is a positive temperature coefficient device. Right. Next one is, we are going to discuss power and voltage, power and energy in a resistor. Power and energy across the resistor. Power and energy. Power, that is power. P equal to power, that is equal to V into I. We know Ohm's law, that is I, V equal to, that is V equal to I into R. So this is the first base equation for P equal to V. And another equation, P equal to, what is the V? That is V equal to IR. So V equal to IR into I, that is equal to I square R. எழுதலாமா? So P equal to V equal to IR, for V I am substituting I, that is I square R. Right. So another equation for power, what is the value of I? I equal to V by R. Right. I equal to V by R. So V into V divided by R, that is equal to V squared by R. So power equal to V squared by R, substituting I equal to V by R, V squared R. This is the power equation for resistor. Next, energy. Next one is energy. energy. So energy you don't by W energy, that is W, that is equal to V into I into T with respect to time, that is called energy. The same way, that is I square R into time, and also W equal to V squared by R into T. That is the equation to find the energy across resistor. If maybe ஒரு சில சமயத்தில் கரண்ட் மட்டும் கொடுத்திருந்தா current and resistance we can find the power, and they gave only voltage அப்படின்னா voltage and resistance வச்சு you can able to find the power the same way as an energy, right? So next we are going to discuss about limitation and applications of Ohm's law. Limitation and applications of Ohm's law. So limitation is applicable only to the constant temperature, applicable only to applicable only at constant temperature, and also the one more thing is applicable only to the linear element. It is only applicable in linear elements. So resistor is a linear element, it is a non-linear element. So linear element enna outputs follows the input. So next types of element la paapom, outputs follows the input the linear element nu solluvom, right? So next, what is the applications? Applications. So என்னென்ன application யூஸ் பண்ணலாம் resistor அப்படின்னா, first there is a bulb, next heater oven. So here are we are using the heat energy, wherever we are using the heat energy அங்கெல்லாமே we are using the resistor, because of resistor dissipates the energy in the form of heat. So எங்கெல்லாம் நம்மளுக்கு heat energy தேவைப்படுதோ we are using, also use it in speed control of AC and DC motors to resist the flow of current. In between you are putting the resistor, that resistor will block the current flow through the motor, then speed of the motor will be controlled, right? So that's all about Ohm's law and resistors. Mostly we are discussing most of the parameters related to resistors and Ohm's law, right? Thank you.